Okay, girls, we're now looking at the second type of induction, mathematical induction, and it's summation. First example is, so example 1 is to show that, or prove that, I suppose it should be prove that 1 squared plus 2 squared plus 3 squared plus n squared equals 1/6 n plus 1, 2n plus 1. Now, it's going to be, so that's our first example. I'll just let you write that down and we'll talk about it. Now, of course, step 1 is to prove true for n equals 1. So step 1, prove true for n equals 1. So, girls, what we've got the left-hand side of the equation over here. This is the left-hand side over here and the right-hand side. See, girls, see how I've got 1 squared plus 2 squared plus 3 squared plus ... n squared. This last term here, n squared, is your formula for how to arrive at each term. So when n is 1, you get 1 squared. That's your first term. N is 2, so when n is 2, you get 2 squared. So n is 1 is your first term. N is 2 is your second term, n is 3 is your third term. So when you see your general, look how all your terms are something squared, something squared, something squared. Okay? So for left-hand side, prove true for n is 1. Left-hand side, your first term, you can either just look at the first term, which is 1 squared, or substitute into the general form of the term, which is n squared. So we've got left-hand side is 1 squared, because it's the, see, look, girls, if you look at the board, 1 squared is my first term, 2 squared is my second term, 3 squared is my third term, and this is my nth term. Okay? So left-hand side, 1 squared is 1. Right-hand side, substitute n is 1 into this expression over here. Okay? So I've got 1/6 times 1 times 1 plus 1 times 2 times 1 plus 1. Are we okay with that? So what we're doing, proving true for n is 1. Even if you can either just look at the first term, which is 1 squared, or substitute 1 here. For your first term, you've got 1 squared. On the right-hand side, you've got 1/6 times 1 is a 6, times 1 plus 1 is 2, times 3. And what's that equal to? 6 on 6, which is 1. Therefore, true for n equals 1. So we've proven the result for n is 1. I'm not going to prove the result for n is 2, but if you did prove the result for n is 2, see, it's a summation. What would you get on this right-hand side if n was 2? You'd get 1/6 times 2 times 3. So that's 1. If n is 2. Don't you get a 2 there? 3 here and 5 here. 5 times 3 is 15 times 2 is 30 on 6. You get 5. What equals 5? The sum of the first two terms is equal to 5. See that? Because this is a summation. So it's not just first term equals first term. If I do n is 1, it's obviously the first term equals that. If I do n is 2, the sum of the first two terms should equal this side when n is 2. What about when n is 3, girls? What would you get over here? If n was 3, you'd get 7 times 4 is 28 times 3 on 6 times a half, that's 14. So when n is 3, on the right-hand side, I get 14. Look when n is 3 here. You're looking at the sum of the first three terms, 1 plus 4 plus 9. That doesn't add up. 14, yes, it does. It's 14. So notice, girls, please, this is very important, that if I put n is 3, I do the sum of the first three terms, because these do not have commas in between. It's got pluses. So if you're talking about n is 3, you're talking about the first three on this side, but just n is 3 on that side, all right? So I've proven true for n equals 1. Step 2 is to assume true for n equals k. That is, we are assuming. Now, girls, as you go on with time, you probably don't need to write this prove true for n is 1. You can just write here, for n is 1, you get that, therefore true for n is 1, and you've proven it. Here, you can write step 2, assume that. Now, I'm going to replace my n with k. What do I write? Assume that 1 squared plus 2 squared plus 3 squared plus ... plus k squared is equal to 1/6 k, bracket, k plus 1 times 2k plus 1. Now remember, we must use the assumption in step 3. So step 2 is to assume true for n equals k. That is, assume that that result is true. Step 3 is to prove that it's... No. With this one, you don't. No rearrangement for this one. Oh, because you can see here, the first question said show that this is divisible by 4. Show that this is divisible by 8. Do you know what I mean? This one is show, look, it's got plus signs. That means summation. This is the sum of a series. Okay? Show that this sum of all these equals that. Okay? For any particular value of n. So, prove true for... So far, proving for n is 1. Assuming for n is k is the same. Now, prove true for n equals k plus 1. That is, you are trying to prove the following. 1 squared plus 2 squared plus 3 squared plus k squared. I'm putting k squared because that's k terms. I need one more. Now, that's the first, look, that's the first term. Wait a sec. That's my first term. My second term, my third term, my kth term. What do I do? Remember, the formula is n squared. What do I write here? Bracket k plus 1 squared. See, girls, this is my first term, second term, third term, my kth term. You know, for the k plus 1th term, the kth term is before it. Plus k plus 1 squared. So basically, this is what you do. You write out, that's the sum of the first k terms, and here's the next term. Equals, now on this side, so on the left-hand side, you have to write the first, all the terms that you've got, and add one more. Are you confused why I'm putting k squared instead of n squared? Because k plus 1 comes after k. Oh, because I'm trying to prove true for n equals k plus 1. So look, if I've got k plus 1 terms, k could be the number 9. I'm trying to prove for 10 terms, k plus 1. So I go 1 squared plus 2 squared plus 3 squared all up to k plus 1 squared if I want to prove true for k plus 1 terms. But what is the term before k plus 1? It's k. So there's all my terms up to k, and there's the k plus 1th term. Now on the right hand side, girls, I'm replacing just n up here with k plus 1. See, girls, on the left I've got a sum of terms. They're my first k terms or n terms, then I'm adding one more. So on my right hand side, I'm replacing the n with k plus 1. Prove true for n is k plus 1. So I'm trying to prove that that's equal to 1/6. What do I write now? Bracket, yep, k plus 1, close bracket. This is the same as the k plus 2 or k plus 1 plus 1. Do you know what I mean? I'm going to go k plus 1 plus 1. And what else? 2 bracket k plus 1 plus 1. Can you see I'm replacing the n up here with k plus 1. So I've got 1/6 k plus 1. Replacing this n with k plus 1. Replacing this n with k plus 1. Now, a lot of people get confused with why I just replace the n with k plus 1 on the right, but I do all the terms and add the k plus 1th term on the left. Because if you want the sum of the first 9 terms, you'd write the first 9 out. If you want the sum of the first 10 terms, you'd write the first 9 terms out and then write the next term out, the 10th. So you have to have all the terms here on the left. See, if I want, have you got this, girls, or not? If I want the sum of the first 3 terms, I just do that one, and that one, and put n is 3 here. You know how we were looking at that earlier? If I want the sum of the first 2 terms, I just write n is 2 here, and just do the first 2 terms there. That's the sum of the first 2 terms. You know how we showed that if I put n is 2 here, I get 5, and I also get 5 there? If I put any's 3 here, I get 14, and if I add the first 3 here, I get 14. If I put any's 4, I should get 16 here. No, I shouldn't. I'd get 30, and I'll get 30 over here, because I'll get the 14 and another 16. So we're trying to prove that this is equal to that. So before we prove that it's equal to that, can we just rearrange what this is going to look like? It's 1/6 bracket. What should it be? Simplify. K plus 1, K plus 2, bracket, 2K plus, 2K plus 2 plus 1, 2K plus 3. So that's what you're trying to prove. That is, you want to prove that 1 squared plus 2 squared plus 3 squared plus ... plus K squared plus K plus 1 squared equals this bottom row. I mean, equals that, but you're not going to go and make it equal that. Simplify it and you make it equal to that. Some people don't write this top row, they go straight to the bottom one, but just make sure you get it correct. Okay, let's start. Left-hand side. 1 squared plus 2 squared plus 3 squared plus K squared. That's your first K terms. Here's your K plus 1th term equals. Well, what can you replace from your assumption? It's staring you in the face. I'll show you what you can replace. All of this, all of that is this, isn't it? Girls, your assumption is that 1 squared plus 2 squared plus 3 squared plus up to K squared equals 1/6 K plus 1, 2K plus 1. So we're trying to prove that all of this plus the extra K plus 1 squared equals that. So what can I replace that with? Yeah, 1/6 K, bracket, K plus 1, 2K plus 1. So that pink bit equals this pink bit. What else do I have to add? Plus K plus 1 squared. So I'm starting with this, and I'm trying to show that this equals that. But what I can do from step 2 is that I've got this. I can replace this from step 2. Remember, you've got to use your assumption from step 2. I can replace all of this with this 1/6 business. And I've still got to add the K plus 1 squared because I'm saying, well, that equals this. Using assumption. I'm not going to write down what the assumption is. Just write using the assumption. Which equals. Now, what do you think you can do? You could expand everything, but I'm not going to. Can you see a common factor? K plus 1 is common. You've got 1, 2 terms. I'm going to take out K plus 1 as a common factor. And what are you left with? 1/6 K, bracket, 2K plus 1 plus K plus 1. No. What you're doing, this is what you're trying to prove. You're trying to prove that that equals that. So you start with this side and you start manipulating it. So what you do, girls, to prove that that equals this, you don't start with this, you start with the left-hand side and you manipulate it until you get that. So I start with that left-hand side and I say, wait a sec, that's like my assumption in step 2. I'm going to replace that bit with the step 2 assumption bit in pink. The assumption bit has been replaced in pink. Got it? That's from my assumption plus K plus 1 squared. So this left-hand side equals this at the moment. I've got 2 terms here because terms are separated by pluses and minuses. K plus 1 is a common factor. I've pulled it out. See, girls, I'm trying to get K plus 1 I've got. I'm trying to get 1/6 K plus 2, 2K plus 3 from all of this. So let's start playing around with it. We've got K plus 1. Keep the 1/6 times K. Okay. Actually, maybe we shouldn't. You know what I want to do? I want to take the 1/6 out. Actually, girls, I need tape. One sec. Okay, now, just going back here, I've pulled out the K plus 1 here. And then I've ended up with 1/6 K, 2K plus 1 plus bracket k plus 1. But if I look at what I'm trying to get, I really want 1/6 as a factor as well. So if I pull out 1/6 to the front here, the problem is that this second term here does not have a 1/6. So the second term, to make it have a 1/6 at the bottom, I'm going to put 6 on 6 in front of this. So I pull out the 1/6 here and there, the 6 at the bottom. I'm left with k, 2k plus 1, plus 6 lots of k plus 1. Then I expand all of this bit here in brackets, and I get 2k squared plus k, plus 6k plus 6. Then I collect like terms, and I've got 2k squared plus what? 7k plus 6. And look what we're trying to get. Let's just write this factorization out, check that it works. What have you got? 2k squared plus 3k plus 4k, which is 7k plus 6. Is it that? So you just write it. Equals 1/6 k plus 1, k plus 2 times 2k plus 3. So we've proven it, which equals the right-hand side. Therefore, let's write out that assumption, that, our little conclusion, step 4. Therefore, if it is true, if true for n equals k, then it is also true for n equals k plus 1. What do I write now? Since, one sec. So, if it's true for n equals k, then it's also true for n equals k plus 1. Then we write, since it is true for n equals 1, then it is true for n equals 1 plus 1, which is 2, n equals 2 plus 1, which is 3, and so on for all n greater than or equal to 1. This question should have told you what values of n you were supposed to use. Actually, it does tell you what values of n you're supposed to use, because it starts from 1 squared. So it does start from n is 1. If it's true for n equals k, then it is also true for n equals k plus 1, full stop. Since it is true for n equals 1, then it's also true for n equals 1 plus 1, which is 2, 2 plus 1, which is 3, and so on for all n greater than or equal to 1. Okay, this is our second example. Prove that 1 squared plus 3 squared plus 5 squared plus ... 2n minus 1 squared, that's a 2. In other words, what's your general formula for coming up with each term on the left? 2n minus 1 squared is your general term. So let's have a look. Girls, just look up at the board instead of writing. When n is 1, let's have a look. What's 2 times 1? Minus 1 squared. See how we get 1 squared when n is 1? Let's look at n is 2. What do you get? 2 times 2 is 4 minus 1 is 3. 3 squared is your second term. Can you see? This 2n minus 1 squared is your nth term or your general term, or the formula that you use to get each term. When n is 3, you get 2 times 3 is 6 minus 1 is 5, 5 squared. See what we're doing? But, so your first term is 1 squared, which is 1. So when I substitute n is 1 on the right-hand side, I'm supposed to get 1. If I put, what's the sum of my first 2 terms? If I put n is 2 on the right, I should get 10. But I'm not going to. N is 2, what do I get? 5 times 3, 15 times 30 divided by 3 is 10. 10. When n is 3, what do you get on the right? When n is 3, 7 times 5, 35 times 3, 105 divided by 3. That's divisible. 35. I should get 35 when I add these. 25 and 10, 35 for the first 3 terms. Okay, step 1. Prove true for n equals 1. Left-hand side, you can either use the formula 2 times 1 minus 1 squared, or you can just write 1 squared. 2 times 1 minus 1 squared is 1 squared, which is 1. Right-hand side is 1/3 times 1 times 2 times 1 minus 1 times 2 times 1 plus 1, which is 1/3 times 1 times 1 times 3. We okay? Which is 1. What's wrong? All right. With the left-hand side, you've got two options. Two options for the left-hand side. Just wait. You can use the formula and put the n is 1 in there, or just write 1 squared. Either way is fine. So you could do this or that. But yes, it is. If you substitute 1, it is. What's 2 times 1? Minus 1. So it's 1 squared. That's the general term. Using this and putting n is 1 should give you that. If you put n is 2 here, you should get that. If you put n is 3 here, you should get that. Girls, for the left-hand side, I'm happy for you just to write 1 squared. But you really are substituting for n is 1, so you should put it into the general. That's the general formula for each of the terms. Now, therefore true for n equals 1. What's step 2? So I should just write assume now. Do you know what I mean? Assume it's true. So in other words, we're assuming that 1 squared plus 3 squared plus 5 squared plus, just copy it all out and just replace the what with a what? N for a K.
Why is this one go 1, 3, 4?
Because when you substitute into 2n minus 1, that's what you get. Look, when n is 1, Georgia, you get 2 times 1 is 1. Sorry, 2 times 1 is 2 minus 1. What's that? If this is the general formula for each term, when n is 1, what do you get? Substitute n is 1 here, what do you get? 1 squared. Substitute n is 2, what do you get? 2 times 2 is 4 minus 1, you get 3 squared. Look here, if you substitute n is 1, you get that. If you substitute n is 2, you get that. If you substitute n is 3, you get that, 5 squared. That is your general term, or your nth term. Wait, you can't even see what I've written. See, when you substitute n is 1 into that general formula for each term, that's the general formula for each term. They should tell us what it is. I should write for n greater than or equal to 1, all right? Sorry. No, you'll only ever be given one general term, okay? And if by substituting n is 1, you get the first term. Substituting n is 2, you get the second term. Substitute n is 3, you get the third term. If you substitute n is 4, you'd get the fourth term, which would be 7 squared, okay? That's just the general term. But on this side, it's the sum of how many terms you've got so far. No, I didn't. That was for part 3. 1/3 K. No, I just substituted it for that. I think you're looking at part 3. So for part 2, you're just substituting the n for the K. For part 3, you need to prove true for n equals K plus 1. Now, it means you've got an extra term than what you've got here. So you write all these out and add your next term. That's your, see, these are a sum of many terms. So we go, that is, we're trying to prove that 1 squared plus 3 squared plus 5 squared plus, now so far I've only got K terms, and now I'm going to add my K plus 1th term, which is 2, all right, just 1 second, 2 bracket K plus 1 minus 1 squared. We're trying to prove that that is equal to, and I'll have to put it on the next row because I've got no room. is equal to this, but replacing the k with the k plus 1. A third bracket k plus 1, 2 bracket k plus 1 minus 1, 2 bracket k plus 1 plus 1. Wait a sec. All right, I need to do something on the board for those that don't understand. I'm going to simplify this because imagine trying to prove something and end up with this result. It's so messy. So we've got a third k plus 1 times what? 2k plus 2 minus 1, which is 2k plus 3, and 2k plus 2 plus 1, which is what? 2k plus 5. So what I'm trying to do is prove that this on the left equals this squiggle on the right. That's what I'm trying to prove. Now to do a proof, you start with one side and you have to manipulate it to get the other side. So I'll start with my left. Isn't that right? 2k plus 2 minus 1 is 2k plus 3. 2k plus 2, oh, that's plus 3, isn't it? What have I missed? Oh, sorry, and that's, I've done them wrong. Thanks for taking so long to tell me, girls. 2k plus 1 and 2k plus 3. I don't know what's wrong with me. Is that better? Thank you. Sorry. What? Oh, because you don't leave it. I got 2k plus 2 plus 1. This one. Oh, no, you don't expand that. I've got my first k. Oh, why didn't I expand that? Because I don't need to. I don't need to. You can if you want, but I'm just replacing. Look, you can do it in your next step. Left-hand side equals. So I just decided not to expand that. The thing is, you're going to start with that anyway and manipulate it to get that. I don't want to manipulate it to get this monster here. It's easier to get that. So start with the left-hand side. 1 squared plus 3 squared plus 5 squared plus 2k minus 1 squared plus this thing. I know it's a mess. I'll fix it in a minute. So we're trying to show, so that equals what? What can I replace from this? Replace that bit with the assumption. We're replacing it with that. 1 on 3k bracket 2k minus 1, 2k plus 1 plus this thing. Now I might start. I'll fix it in the next step. All right? Equals. I probably should have fixed it. So, yeah. So I've got, have you got that other bit? So this is using the assumption from step 2. So all I've done is replace the squiggle with that. Girls, what you'll always do is replace the first k terms with your assumption, which is 1/3 k, 2k. Wait. Girls, do you get what I've done? It's not. I've got all of that plus this. So I replace this bit, which happens to be that. I'm replacing that with this, and I've still got to add this on. Plus, what have I got here? 2k plus 1 squared. Oh, it's all right. Good. No, so I just write it all out with k plus 1 terms. I'll replace the first k terms with the assumption here, and then write out the last one. Simplify that. Now, what? No, you don't expand. You factorize. Can you do it for me? What do you pull out? 2k, yeah, and the 1/3. Look at what we're trying to get at the end. You're trying to get 1/3, 2k plus 1, k plus 1, 2k plus 3. Pull out the 1/3. Don't make the mistake like I did before. Pull out the 1/3 and anything else that's in common. 2k plus 1. Now, if you pull out the 1/3, what do I just do with this? Put it 3 on 3, and now you've got a 1/3 to pull out. Does it make sense? So I'm pulling out the 1/3 and the 2k plus 1. What am I left with? I've got a k, a 2k minus 1, plus a 3, and one more of the 2k plus 1s. Okay? See why I've put 3 on 3? So I can pull out a 3 denominator. I've just thrown that 3 on 3 in there.
Is that meant to be where your pinky is?
I'm trying to pull out the k plus 1, which is easy to pull out, but I'm trying to pull out the third. I've got a third for the first one, but I don't have a 3 on the denominator of the second term, so I'm putting 1 in and balancing it out with the 3 on the numerator. So when I pull out the 3's on the denominator, I can see I've clearly got a 3 left on the numerator for the second term. So now let's expand. A third, 2k plus 1, 2k squared minus k plus 6k plus 3,
Oh, I see.
2k plus 1, 2k squared plus 5k. Now this is where you look at the answer, see what you're missing, and hope. See, you're missing, you got the third and the 2k plus 1, but you're missing the k plus 1 and the 2k plus 3. Just have a quick check. 2k squared plus 3k plus 2k, that's plus 5k plus 3. It's going to work. So just write it in, a third, but don't write it in the proper order yet. You can write it as 2k plus 3, k plus 1, because that's what you're trying to get. You look up here at their answer and say, I'm missing that one and that one. Let me write it in and then I'll check if it's right. 2k squared plus 2k plus 3k plus 3, yes, that is that. Which equals your right-hand side. You can write them in order now. K plus 1, 2k plus 1, 2k plus 3 equals right-hand side. So therefore, if it's true for n equals k, then it is also true for n equals k plus 1. Since it is true for n equals 1, then it is also true for n equals 1 plus 1, which is 2, 2 plus 1, which equals 3, and so on for all n greater than or equal to 1. Another one. And in an exam, you'll be doing this question in 5 minutes. Don't tell me no. All right, I'm going to try another one. Ready? I'll be doing videos anyway. Tonight. Ready? We'll see. Depends what I'm doing. All right. Pull 3. Prove that 1 over 1 times 4 plus 1 over, and it's not, girls, it's not 0.4, it's times. 1 over 1 times 4, but you'll see them written as points. How do we know it's that? Because substitute n is 1. What do you get? 3 times 1, 3 minus 1 is 1. 3 times 1 plus 1 is 4. When n is 2, 3 times 2 is 6 minus 2 is 4. 3 times 2 is 6 plus 1 is 7. They're multiplication symbols. So proving that that left-hand side, the sum of all that left-hand side equals that right-hand side for n greater than or equal to 1. Step 1. All right, I'm just going to write for n equals 1, what do you get? Left-hand side is, use the formula, or you can just use the first term. 1 over a quarter, you could just write that. 1 over 1 times 4, which is a quarter, or you'd substitute in here. 1 over 3 bracket, 1 minus, do you know what I mean? But you will get that. What's the right-hand side for n is 1? 1 over 3 times 1 plus 1. Therefore, true for n is 1. So, girls, once you start getting used to this, you don't have to write prove true for n is 1. You go for n is 1, therefore true for n is 1. Right? Step 2, assume, and you can just write assume. Step 2, assume that 1 over 1 times 4 plus 1 over 4 times 7 plus 1 over, what do I do? 3k minus 2 times 3k plus 1 equals k over 3k plus 1. Georgia, step 3, your specialty. Step 3, you have to prove, I'm going to write prove true for n equals k plus 1. What am I trying to prove? In other words, I'm trying to prove, Georgia, what do I write on the left-hand side? I write it all out, plus the next one, plus, write out the k terms, then write out the k plus 1th term. We might actually do the summary one. What do you get if you get k plus 1? I don't want to write 100 different things. What do you get? 3k plus 3 minus 2. What do I get? I'm substituting. Do you know what I mean? I'm working it out as per Lydia's suggestion. 3k plus 3 plus 1. Just don't stuff it up. If you're going to do that, I've substituted in the k plus 1 there. Don't make a mistake. Equals what? Equals k plus 1 over. So I've simplified, all right? Got it? Do you get? I've gone 3. You know what? I might just go 3 k plus 1 plus 1, which is k plus 1 over 3k plus 4. So that's what we're trying to prove. All right, what I'll do, have a go. I'm going to stop this video now because it's already 36 minutes. I will continue. Or will I just do it now? Left-hand side is 1 over that plus 1 over this plus all of this plus the next bit. So that equals, what do I replace? What do I replace? I replace, girls, I replace all of that with k over plus 1 over. Girls, it looks like I'm adding fractions with different denominators. Yes, let's make a common denominator. They've both got 3k plus 1. What's the first fraction missing? 3k plus 4. It looks good to put a 3k plus 4 down there, so we go k times 3k plus 4 plus 1 all over. Can we just write the single denominator there? So girls, my common denominator is going to be 3k plus 4 times 3k plus 1. The second term's got them both, but the first one's missing the 3k plus 4. Girls, expand. What do I get? 3k squared plus 4k plus 1 over this. What do you think I should try and do? Yeah, I think so. And let's hope you get, what do you really want to get rid of down the bottom? Girls, look what you're trying to get. We don't want a k plus 1 down the bottom, a 3k plus 1 down the bottom. Let's hope the 3k plus 1 is a factor up the top. I'm going to write it as a factor and work out the missing factor. Well, what would it be? K. So what's that? 3k squared plus 3k plus 1k plus 1. That works. What cancels? I've got a problem. Oh, no, I don't. Which equals k plus 1 over 3k plus 4, which equals what we're supposed to get. Yay, therefore, conclusion. So that's what we're trying to get, and we got it. Cool. So if it's true for n equals k, okay, you can do the conclusion. Bye-bye. Just write that down. I'll do another video tonight.